Hi, everybody. This is section 6.2. It's just a continuation from last time, 6.1, normal distribution and the normal curve. Just as a reminder, don't forget about the Z formula. You should have this written down. Remember, there's one for population and one for standard deviation. One for population and one for sample. This is pretty much the standard curve. Z is the Z value on the curve. This is the value, the extra value that they're talking, that they normally mention. This is the average, and this is the standard deviation. So this value here is just where on the curve it is, where exactly on the curve it is. So if I bring this up, we want to find out what percent of the graph is shaded in. We have to know what this value is, Z value. It's not a Z value. How do I know it's not a Z value? Anybody know how I know? If it was a Z value, then the center would be 0. Don't forget, the center is always 0. So here it's just saying the average. The average is 5.2. That's an average has a Z value of 0, right? So this is not a Z value. It's just the actual average. Assume that it's normally distributed. So we're going to use the normal curve. Standard deviation is 0.3. Find a percentage of people that have less than 5.4. Here's 5.4. It's more than 5.2, the average. And we want to find out the percent that have less. Everything's shaded in to the left because going to the left is less than 5.4. So we really want to find the Z value. We know this Z value on the left-hand side. This is negative infinity. So we're going to type in a negative 99 Z value for the left side, for the lower boundary. We just don't know what we're going to type in for the upper boundary. So we're going to use the formula up here to find Z. X, and X is the value we're talking about, 5.4. You see, that's the 5.4. The average is 5.2. There's the average, the mean. Divided by the standard deviation, it was 0.3. So if I put that in my calculator, I get 0.67. If I round this, it's 0.6666. Round all Z values to 2 decimal places, I get 0.67. So the Z value here is 0.67. So this is my lower, this is my upper, and I want to find out what percent is shaded in. So I'm going to go to my calculator. Negative 99 and 0.67. So if you remember how we did this last time, we've created a new calculator page, number 1. And then we did menu 552. The lower boundary here was negative 99, which was infinity. The upper boundary we said was 0.67. And then mean is 0, standard deviation is 1. And I hit OK. And there's the percentage, 0.7486, if I round it to 4 decimal places. The percentage number should always be 4 decimal places. The Z value should always have 2 decimal places. Okay, so let me go back. So we already said we found let me just recap what we just did. We said left side, the Z value was -99. And the right side, the Z value equals 0.67. And when we did that in our calculator, we got 0.7486 rounded to 4 decimal places. So about 74%, 74 to 75% is shaded in. Now, remember this number, 0.7486. There's another way to do this problem, and I'm going to leave it up to you which way you want to do it. Let me grab my calculator again. I need to write some information down because I always forget as soon as I leave it. I always forget. So we know the mean is 5.2. Standard deviation was 0.3, and our value is 5.4 that we're talking about. Okay, so I'm going to go to my calculator. There's another way of doing this on our calculator. And some of you might have figured it out already. I should just cancel that, right? Where's my... There it is. Okay, so if I go to menu 552, if you look, our mean on here says 0, but you can actually put the real values in here. Right now for 0 and 1, you use that if you're going to type in Z values up here. But if we don't want to type in the Z values, we can type in the actual numbers. The mean was 5.2. The standard deviation was 0.3. Our lower boundary was in negative infinity. I'm just going to type in negative 99999999999. That's really close to negative infinity. The upper boundary was 5.4. Do you see on the graph, the far right was 5.4. The far left, the lower boundary was negative 9999999, negative infinity. So you can type all this in so you don't actually have to calculate the Z value. So when I go to OK and hit enter, we get the same answer. Well, it's actually not exactly the same. 747, it's not the same answer. I wonder why. Maybe I need to put more for infinity. Oh, because we put, wait, why did we put? Oh, it's going to be a little different because our fraction, if we put that in fraction form, it's 2/3. So I think it's because we rounded it in there. 0.67, 0.67. Well, yeah. Let me try something different on there. I'm going to go to menu 552. And my lower boundary, I'm going to hit negative 99. Upper boundary, we already said 0.667, but what in fraction form, it was 2 divided by 3. And then I want to see how this changed it. And if you look now, they're both the same. The way where I just punched in all the real numbers and not use Z, and see, because I rounded this. This was 0.66666666. I used 0.67. That's why it was off a little bit. It was just off a little bit. So this is, they both match up now because they're both the same numbers. One's in regular numbers at the information they gave us. The other one is in Z's. Okay. So you can do that either way. It doesn't matter which way you do. I think it might be easier doing the Z, well, calculating the Z. That's actually a little harder, but it gives you good practice because you're going to have to calculate Z's later on. All right, so that's what I want to do here. Maybe calculate, see, they use 0.67. So in reality, 0.67, that should have been 0.2 divided by 0.3, which reduces as the fraction is 2/3, 0.666666. All right, so let's try this one. And our average, the average is 28 pounds. Well, we didn't need that because we know the center is our average. And we want to go between 27 and 31. 27 is the lower and 31 is the upper. The only thing I don't know is standard deviation. Standard deviation is 2. Standard deviation equals 2. So I'm going to use that for my calculator. 27 is the lower, 31 is the upper, and standard deviation equals 2. So if I go to my calculator now, I'm going to go to menu, 552. The lower we already said was 27. So I'm not even putting Z values in. The upper was 31. The average was 28. And the standard deviation we said was 2. So when you type that in, it tells you what percent of the graph is shaded in, 0.6247. And you should get the same thing if you type it in Z values and you don't round them. If you're typing in Z values and you're trying it that way, I mean, you're not wrong, but this is the more accurate. I think this is simpler, so you don't have to round anything. So for this one, if we looked at it, we got 0.6247. So this is about 62% shaded in. All right. This one, I'm going to use Z values. I'm going to do a Z value. So here's the Z value of, first of all, -99 at the end. I need to find the Z value for this. And the formula was Z equals X minus the average over standard deviation. The X is 106. The average was 120. And standard deviation is 6. So the Z value in that place is -2, I believe. 106 minus 120 divided by, no, it's not -2. Divided by 2. Or divided by 6, sorry, divided by 6. And I get a Z value of -7/3. It gives me a fraction. That's the same thing as -2.33333333. If we rounded to 2 decimal places, the Z value would be -2.33. Okay, so on my calculator, I'm going to put -99 and 2.33. So I'm going to do menu 552. Lower boundary was -99. Upper boundary was -7/3. 7/3, 7 divided by 3. I'm still gonna punching the right button in. Hang on, I'm gonna get there. There, is that 7 divided by 3? Yes, I think that's. So we use Z values. So if we use Z values, mean has to be 1 standard deviation. I mean, mean has to be 0, standard deviation has to be 1. And there is the percent shaded in. It's a very small percent, not even 1%, really close to 1%. And if you look, I mean, that's what it is. Very little is shaded in. 0.0098 rounded 81 rounded to 4 decimal places 0.0098. So not even 1% is shaded in. All right. So this is the section where we have some word problems and we have to actually draw. I think it'd be best to draw the picture. And we're dealing with normal curves. As soon as you say normal curve and up is test scores are normally distributed. It says at the very end. So we're using a normal curve. If I could actually draw a nice normal curve, there we go. It says candidate must score in the top 10%. Candidate must score in the top 10%. So if I look at this, the shaded in has to be the top 10%. Or 0.10. The test has a mean of 200, standard deviation of 20. Find the lowest possible score to qualify. So we need to know what this score is. So we do have to find the Z value here. We need to know what that Z value there is for the top 10%. It says top 10%. Anybody know how to go about that? How to find the Z value for here? Anybody remember how to do that from last time? Anybody?
We know it's got to equal 1, right? So we have to subtract it from 1.
Subtract this from 1?
Right.
Yeah, and we get 90%. So this part is 90%, but we still have to find a Z value. So if we know the percentage to find the Z value to the left of it, so we have to know the percentage, what's shaded in to the left. We're trying to figure out the shaded in to the right, but right now we're just trying to find the Z value. Remember, the inverse norm feature tells us the Z value to whatever we have percentage shaded into the left. If we say 90% is shaded in red, then we can do the Z value. And I'll show you what I mean. So 90% is shaded in to the left. I'm going to go to menu 5.5, and we're doing inverse norm 3. And what area is shaded into the left? 90% or 0.90. And it's going to tell you the Z value there. I mean, this is, how to get about this answer. It's a little longer, but it tells you how to get about the answer. And there's our Z value, 1.28. So our Z value for that problem is 1.28. We did the inverse norm. That's what we learned last time, that if you have a percentage shaded into the left, we do the inverse norm. So here, once again, we want to find the top 10%. This is 10%. And then, so this is 90%. And this Z value, if we looked at our thing, says 1.28. 1.28. So we're not done, because that's the Z value. We want to know what score to be in the top 10%. Top 10%. So the mean is 200. Standard deviation was 20. And we want to know what X equals. That's the value. We want to know what X equals to get a Z score of 128. And the formula was Z equals X minus the average over standard deviation. Z equals, we're trying to find the X. The average was 200 and standard deviation was 20. So, and now I can erase the Z because we know that Z value is 1.28. There's a lot of work for this problem, and you will have these on the test. Okay, so now I need to take the 20 to the other side by multiplying by 20. 1.28 times 20, 1.28 times 20 is 25.6 equals X minus 200. You see, I multiply this side by 20, multiply this side by 20, and those cancel, and this is what I'm left with. Take the 200 to the other side by adding 200. Add 200, and X equals 200 plus 25.6 is 225.6. So what is the lowest score? This is a Z of 1.28. It also corresponds to an X value of 225.6. So find the lowest score to qualify in the top 10%. The lowest score to qualify was 225.6. So I mean, that's a little work to do, and you can't really do any shortcut around that, I don't believe, on your calculator. So let's do the next one. These word problems get a little tricky. Here's the next one. Normal curve, so I'm going to draw a normal curve. Select the middle 60%. Here's where a Z is 0. So the middle 60%, we want to select the middle 60. That means we want 30% on this side and 30% on this side. So we need to find these two Z values, because this is 60%. You see, all this is shaded in 30 and 30. It says the middle 60%, 30 on the left and 30 on the right of a Z of 0. That's the mean. So we need to find these two Z values. Well, this is actually kind of easy, I think. First, find these two Z values. We can do what we just did with the inverse norm. Can somebody tell me what this percent should be? The left part. You should be able to tell me that percentage. If half of this is 50%, we already know 30%, this has to be 20%. You see, 20% and 30% is 50%. And this is another 20% since we did the middle 50. So now this is all total 100. So if I do inverse norm with 20%, I'll find the Z value because 20% is to the left of this Z value. Inverse norm 20%. So I'm going to go menu. I'm not going to pull it up because I'll erase everything I just did. I'm going to go menu 55 number 3. And the area is 20%, 0.20. And when I hit enter, I get a z-value of negative 0.84. Now, if you do a z-value of 30, 30, and 20, everything to the left of this, that's 80, a z-value of 80%, you get a positive 8.4, positive 0.84. If you do same thing here, I did an inverse norm of 80%, because everything to the left of this line is 80%, and there's the other 20. Remember, inverse norms only, you can tell you the z-value for the percentage you say to the left of that. 80% to the left of this is a positive 0.84. So these are our two z-values. We need to find now the actual scores from, we want to find the actual scores for the blood pressure. We know the average blood pressure is 120. That's the average. Standard deviation is 8. And we need to know what this blood pressure score is and this blood pressure score is. These are z-values. We know our average blood pressure is 120, a z-value of 0. So if we use our formula, z equals x minus the average over standard deviation, then the z is, this first one is negative 0.84. Now we're trying to find the x value. The average was 120 and the standard deviation was 8. Take the 8 to the other side by multiplying by 8, negative 0.84 times 8, negative 0.84 times 8. I get negative 6.72 equals x minus 120. Then add 120 to both sides. And you end up with x equals 13.28. 113.28. So the left score is 113.28. Find the upper and lower readings for blood pressure. So the lowest blood pressure, the mean would be 113.28. Now we have to find this z-value. So it's going to be the same thing, except we're not putting a negative here. It's going to be positive 0.84 equals x minus 120 over 8. Multiply 8 times 0.84, I get a positive 6.72 equals x minus 120. Now add 120 to both sides. 120 plus 6 is 126.72. So this z-value ends up being 126.72. So these are my two blood pressures. It says, where is your blood pressure in the middle? 60%. Between 113 and 126. Those are the middle 60%. So you had to find the z-value for each one. And before you could find, we found the z-values using the inverse norm, but then you had to change it to the actual numbers, the blood pressure reading numbers. All right. Yeah, there's a storm out there, right? It's not really a storm. It's just a little rain in my neighborhood. And I think that's it. I don't think we're going to do the rest of it. If they ask, construct a histogram. If they ask you to do this on the homework, don't forget, you're going to have to go back to like week 4 or 5 I think in week 4 or 5, we constructed the histogram. So if they give you data in the homework and say construct a histogram, go back to week 4 and 5 on your calculator and learn how to do that on your calculator again, because you're going to have to do that. And they ask, is this a bell-shaped curve? Well, if you look at it, it goes up and then it comes down. So it's kind of like a bell-shaped curve. It's not a perfect bell-shaped curve, but we can say it's an approximate because the highest is in the middle and then it goes down on both sides. So it's approximately a bell-shaped curve. If you put this in, create a histogram and say, oh, is this a bell-shaped curve? Is this a normal curve, bell-shaped or a normal curve? It's approximately, it's not exact, but it's close. All right. And I think that was it. Let me go to the 6.2 homework really quick and see what we have there. Oh, there's a 6.3 in here, but I don't think we're doing 6.3, so I'm going to have to delete that homework. Okay, so let's preview 6.2 homework. And there are 12 problems in here, okay. Let's see if it works with the, where you're not finding the Z values, you're just plugging the numbers in. The average annual salary, this assumed distribution is normal and standard deviation. Find the probabilities of the earnings of a teacher select, wait, find the probabilities. Okay, they want to know the probabilities of these two. So if we draw this normal curve, we know the average is 28,800. The average, wait, that's not the average. The average salary is 47,750. And we know we have 28,800 is the high, and then 37 is this is the lower boundary. This is the upper. Now 37, if you look, 37 is not over here. 37 is right here. It's to the left of 47, 47,000. So this is 37,700. We want, it says, find the probabilities that the teacher makes between these two. So we want to know what percent is shaded in. That's the probability. It's the same thing as saying probability, or what percent is shaded in. Between 28,800, I'm going to write this down, 28,800 and 37,700. The average is 47,750, and standard deviation was 5,680. Okay, so I'm going to put this into my calculator. Let's go to the calculator, and we're going to go to menu. Let me hit this thing on first. Menu 552. Average was, for this problem, the average was 47,750, 47,750, and standard deviation was 5,680. And when I hit enter, I get about 95%, 0.9570, 0.9570. So once again, 0.9570. Check my answer. There it is. Okay. Everybody okay with these? It's really not too bad. It's just, it takes practice. You can't do these without practice. They're going to go to percentile scores. So you're going to, what is the 96th percentile score? Well, let's do this one. Let's do this one. Here's the normal curve. The average is 1028 for the SAT. Standard deviation is 92. What is the 96th percentile score? So 96 means you did better than 96% of the people. That, I mean, if you look, it's the Z value would be somewhere over here because this is about 96%. Do you see? I mean, it's somewhere over there. About, I mean, 96% is almost all of it to the left. The top 96%, you know, you're in the top 4%, which is you're in the 96th percentile. And it says what we want to find the score. We want to find this score. And one way of doing it, we have to find the Z value for the, oh, actually, yeah, we have to find the Z value because the lower value here, the Z value is -99, but we don't have anything to type in here and we can't find this. Oh, actually, we can find this. We can find the Z value, but then we have to change it to an actual score. We have to change it to an actual score. So to find the Z value for 96, we do the inverse norm for 96% because it'll tell us the Z value for 96% to the left of it. So we do inverse norm, menu 553. And the area is 0.96. The U and 1 stay as 0 and 1. When I hit enter, it tells me a Z value. My inverse norm tells me a Z value of 1.75. So this is 1.75. But we need to find the score now. The score is the X value. The Z value was 1.75. We want to find the X value, the score. The average was 102.8 and the standard deviation was 92. So we're trying to find this X. First, we multiply both sides by 92. 1.75 times 92. And wow, we get 60. We get 161 exactly. No decimal. 161 equals X minus 102.8. Now we add the 102.8 to it plus 102.8. And my X value then is 263.8. And it says to the nearest whole number, and this is 264. So my score here should be 264. Hopefully. And it's wrong. So we're going to go to show an example. And I'm thinking 96, if you're in the top 96%, that should have been it. The probability Oh, wait. Okay, hang on. This is, what is the 80th percentile score? They actually got us. Oh, that doesn't make sense. Oh, we can just do the inverse norm for that, but we should have got this. That was the answer. Let's do the inverse norm for that one. All right, let's do the inverse norm for that one. But we should have still got the same answer. We should have still got the same answer. I'm going to do the inverse norm. Menu 553, and the area is 96%. Unless I didn't use 96%, what did I use? I used 0.96. The average score was 1028, and standard deviation was 92. Oh, I might have typed in those backwards. And I get my score that I get here. Oh, my score I get is 1189. That doesn't, yeah, this 264 doesn't make sense. Now that I look at it, it doesn't make sense at all. The actual score I got, let me show you. Well, let me put it in there and make sure it's correct first. 1189. Yeah, that's correct. And then I'm going to figure out what I did wrong. But let me show you on the calculator. So on the calculator, we did menu 552. And we want to do, I'm sorry, menu. Let me hit clear. Let me get out of this. I want to cancel that. Menu 553. And the area was 96%, 0.96. The average that we typed in, whatever I typed in for the average, let me look at it really quick. The average was 1028 and standard deviation was 92. The average was 1028 and standard deviation was 92. And then when I hit okay, I got 1189. Now let's figure out why I didn't get 1189 when I did it the other way. We already said 96%, and we got a z-score of 1.75. So we got a z-score of 1.75. We want to try to find the x value. The average, oh, I think I typed in the wrong average. The average was 1028 and standard deviation was 92. I did. This was the wrong number I had used, or maybe I used a decimal instead of that number. So it's 1.75 times 92. And then I want to add 1028 plus 1028. And I do get an x value of 189. So, I mean, 1189. And so we get the same thing here. All right, so that's I mean, this is a tough section. I think it's a tough section because there's a lot. You have to draw these. You have to draw these to get it correct. Let me just look through a couple more questions. I don't really want to do them all. Okay, so these are word problems. That's all we want to do, at least one of them. Okay, let's do this one. I think we're going to do that one. Number 6. Yeah, let's do that one word problem and we'll call it a day. So here's our word problem. Once again, I like to draw the normal curve. It says the average is 24,600. Standard deviation, 15,000. This talks about prices of homes. Find the minimum and maximum contractor needs to satisfy the middle 84%. So we want the middle 84%. 84 divided by 2 is 42. 42% on this side, 42% on this side. That's 84%. We need to find the values right here. And we can do that using inverse norm. So first I'm going to find the inverse norm. I'm going to find the value for this spot right here. Can somebody tell me what percentage I should find when I use inverse norm? What percentage should I use in inverse norm? If I want to find this Z value, or not that Z value, but that value, what percentage should I use? Inverse norm, 553. We should, if this is, yeah, 8% exactly. If this is 42%, we should use 8%. 8%. So I'm going to go to my calculator, do menu 553, type in 8%, 0.08. The average is 246,300, and standard deviation, we already said, was 15,000. And it's going to tell you the actual, that's the minimum price. And the minimum price is 225,224. So let me type that in. 225,224. And now I need to find the value for over here. This Z value. What, and I'm going to do the inverse norm. I'm going to do the same thing, inverse norm here, 553. And I'm going to do everything here. So this is 50%. These two add up to 50% and 40 more. 50 and 42 is 92%. Do you see? That's 92%. So I'm going to do inverse norm, menu 553. Area is 92%, 0.92. The average, once again, was 246,300. 246,300. Standard deviation was 15,000. And this value, it's not the Z value because I didn't use 0 and 1 in the average and standard deviation. I used the actual numbers. I got 26,736. So we're going to type in 26,736 and check our answer. And it looks like we got it correct. So there's a lot. I mean, you have to draw and you have to understand the percentages in here. Adds up to 100%. Inverse norm will tell you the Z value or the value you're looking for to the left of the line, you know, to the left of the line if you have the percentage. So if I want to find this value, I have to know what percent is shaded in all to the left of it. If I want to know this value, I have to know what percentage shaded in to the left of that value. That's the inverse norm. All right. That's all I had today. I'll hang around if there's any questions.
Thank you.